Okay, so we're going to prove that the DIrichlet function is nowhere continuous, which would prove that it is non-integratable. So the DIrichlet function is one of the form f of x equals 1 if x is rational or 0 if x is irrational. So to prove that f is nowhere continuous, we're going to approach this by way of contradiction. So by way of contradiction, we're going to suppose that f is continuous at a general point A in the reals. So suppose f is continuous at A in the reals. Then, by definition of continuous, we know that for all epsilon greater than 0, there exists a delta that I can never draw, a delta greater than 0, such that, let me make sure I get this correct, such that for all x in the reals with absolute value of x minus a less than delta, then absolute value of f of x minus f of a is less than epsilon. So for our proof here, we're going to let epsilon equal 1. Then that implies that f of x minus f of a would be less than 1. So we can rewrite this statement here this absolute value of x minus a is less than delta can be rewritten as a minus delta is less than x, which is less than a plus delta. So now that we have our definition of continuous, we're going to take two cases. So case 1, and we're going to try to come to a contradiction in both cases. So case 1 is suppose a is rational, if a is rational. So by our definition of our function, if a is rational, then our function takes on the value of 1. So f of x equals 1. By the density of the irrationals, then we know that we can choose an x within this interval such that x is irrational. Because our contradiction that we want to come to is that when we take f of x minus f of a, it's not less than 1. So the only way that we can do that with this function is if we know that a is rational. So then we know this should be f of a is 1, then we want to make f of x 0. So we need an irrational within that interval. And we know that that 1 exists because of the density of the irrationals. So by the density of the irrationals, pick an x within this interval, the a minus delta, a plus delta, such that x is irrational. This implies that f of x would be 0. So then, when we apply it to our definition of continuity, we see that, sorry, I accidentally stopped it. okay, we see that f of x, so f of x, because we know f of x would be 0, then it would be 0 minus f of a, which we know to be 1. 0 minus 1 is less than 1, which is 1 is less than 1, which is a contradiction. So we got case 1 to a contradiction. Now let's work on case 2, which is if a is irrational. So if a is irrational, then f of a, by our definition of a Dirichlet function, f of a is 0. By the density of the rationals, we know that we can choose an x, pick an x within the interval a minus delta a plus delta, such that that x is rational. And thus, f of x would equal 1 in that case, that x is rational. So then we have a similar case where we have f of x, which is 1, minus f of a, which in this case is 0, is less than 1. And that means that 1 is less than 1, which is a contradiction. Thus, we reached a contradiction in both cases, so then we know that nowhere is this Dirichlet function continuous, and thus is not integratable.